This video is going to go through the steps for solving linear inequalities. And you've got this table here that describes some of the steps or outlines some of the steps that you can take. And once again, just like equations, you can always substitute your answer back in to the original statement just to make sure that it is true. One thing I do want to point out is make sure that you remember that whenever you are working with inequalities, the direction of the inequality is going to change if you divide or multiply by a negative number. So as soon as I divide or multiply by a negative, I have to remember to switch my inequality, which means if I'm starting with a less than, it's going to become greater than, and so forth. Alright, let's look at the first example. So I'm solving my inequality. Remember, just like an equation, I'm looking to isolate my variable. In this case, it's x. So first thing I need to do is get rid of this fraction. So since I'm dividing by 7, I can multiply both sides by 7, and that will get rid of that fraction on the left-hand side. Negative 3x minus 4 is greater than 7 times 5, so 35. I'm going to add 4 to both sides. Negative 3x is greater than 39. And then lastly, I'm going to divide both sides by negative 3. Remember what we just said about the inequality switching directions as soon as I divide or multiply by a negative. So I've divided by negative 3. So my inequality, instead of greater than, is going to become less than. And when I divide, I'm going to get negative 13. So there is my inequality statement. When I solve inequalities in one variable, meaning I'm just dealing with a single variable like x, then I could also display my answer on a number line. So I've got 0, negative 13, and I'm describing values that are less than negative 13. So I'm going to put an open circle around negative 13 because it's not equal to 13. It doesn't have the line underneath it. And then it includes all values that are less than, which would be to the left. Again, solving, I'm going to bring my variables to one side. I've got 7x plus 4 greater than or equal to 11. 7x greater than or equal to 11 minus 4, which is 7. And then divide, I get x is greater than or equal to 1. Notice that I did not switch my inequality, the direction of my inequality, because I divided by a positive number. So my answer is x is greater than or equal to negative 1, or excuse me, positive 1, on a number line. That would give me a solution that looked like this. Again, now it has equal to, so that means I'm going to put a closed circle at the value of 1, and I'm going greater than, which is values to the right are greater than. Here I'm going to simplify first by distributing my negative 6, so I get negative 24x minus 36 is greater than negative 111. I'm going to combine these that are like terms, so I've got negative 24x minus 39 is greater than negative 111. Now remember, these are on the same side of the inequality, so that means that I just combined negative 3 and negative 36. I didn't add it to both sides like I would if they were on opposite sides. Alright, now I'm going to add 39 to both sides, and negative 111 plus 39 is going to give me negative 72. And then I'm going to divide both sides by negative 24. And that's going to give me 3. But remember that my inequality has to switch directions because I divided by a negative. So there's my inequality, my number line, and I want values that are just less than, not equal to. So open circle and arrow to the left. Again, following correct order of operations, so I'm going to simplify by distributing. I get negative 6 plus negative 42k, or minus 42k. And then 7 when I distribute, plus 42k, less than or equal to negative 2. In this case, when I combine like terms, I have negative 6 and 7 become 1. Negative 42k and 42k cancel each other out. So I have 1 when I combine these is less than or equal to negative 2. And that is not a true statement. Therefore, I have no solution. Alright, going to distribute once again. Negative 10 minus 12n is less than 48 minus 12n. So I end up, I'm going to add 10 to both sides. Negative 12n is less than 58 minus 12n. Add 12n to both sides. Notice that cancels, so that becomes 0. And this is a true statement. 0 is less than 58, unlike the last problem. So since it's a true statement, I would have an infinite number of solutions, but my solutions are only going to be my real numbers that exist on my real number line. So my answer would be all real numbers.